Hey guys, welcome to day 7. Let's start a daily challenge. Alright, so question number 1519, number of nodes in a subtree with the same label. Okay, another tree problem. You're given a tree connected undirected graph that has no cycles, consisting of n nodes numbering from 0 to n minus 1 and exactly n minus 1 edges. The root of the tree is 0, and each node of the tree has a label, which is a lowercase character given in a string. Labels. Okay, the node with the number I has the label labels I. The edge array is given on the form edge I. The edge array is given on the form edges I between A and B, which means that there's an edge between A and B in the tree. Return an array of size n, where answer I is the number of nodes in a subtree of the ith node, which is the same label as the node. Okay, so a subtree of type T is the tree consisting of a node T and all of its descendant nodes. So let's see. So I'm guessing that this is another recursive definition where we can say that the current ants value, the current answer value, should be the number of times that its subtrees contain the same character plus 1, right? And let's confirm that understanding labels A, B, A, A, B, A, E, D, C, D. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 1, 1, 1, 1. Okay. It's pretty simple. This is similar to the 6th problem that we solved yesterday. Let's start coding. So initially, I guess I would have to construct that array or that a data structure which represents a tree, because currently we're just given edges. Let's call this data structure tree. It's going to be a dictionary, and let's see, it's pretty standard. So for edge in edges, we're going to say that A is equal to edge 0 and B equal to edge 1. B if A not in keys in edge keys, now I'm going to say that tree of A is going to be a new empty array where all of its children are going to be stored. And let's call this to populate the child array. So now that we have a representation of the tree, let's print it and make sure that this runs correctly. If A not in edges keys. Tree. 0, 1, 2, 1, 4, 5, 2, 3, 6. Sounds good. So now, now that we have a representation of this tree, let's go ahead and implement the DFS function that we're going to use to traverse the tree. Current, and then what else do we need? We probably need the here we probably need the labels for sure, and the tree. Okay, and this is going to. Now let's think about how to define this. How to define this recursive definition for subtrees that contain the same character as you. So starting off with our edge case, that if the current is not in the tree, it must mean that we're on the end of the tree. Let's see, if current not in tree keys, then return a data structure that tells us what is the current count, the current label. The current label. Oh, we also need the label. Oh, we have the label. Label current. This is going to be the character that that we care about, and the character that we care about in the leafmost node to this parent, we only have one character and its count is 1, so D is equal to 1. Now, let's see, labels. The recursive definition here then would be that for all the children of the parent node, we have to count, or we have to create this structure telling us what each character's count is. So current label count is going to be 0, and children is going to be the tree of current. For child and children, we're going to, for child and children, we will now have to, we're going to, oh, so this label count, or res val, is going to be the current label, and say 1. And if a this is going to be our return value, actually. Return ret val. Now, how do we populate this ret val, right? Well, the subtree label count is going to be initially an empty. Oh, no. Subtree level count is going to be our function self DFS, with the current being the current child that we're looking at. Labels and tree. Let's say that this returns a dict of str and an array of ints. DFS, spelled it wrong. And so now for each, because we have to reconstruct this ret val that we're going to return for L in subtree labels. It's a little shorter. Labels keys if L not in ret val keys, if the letter that the subtree labels dictionary has is not in the ret val, then we're going to say ret val L and set it to the subtree's value of the L. No. Initially, we're just going to do this as an empty, as a 0. And here, we're going to say ret all. Yeah, let's set it as 0, just to be just to not have that else statement, in which case we could do that. If it's not there, then add the actual value, else set or append the value. We're just going to have, if it's not, then initialize this value, and ret val of L plus equals subtree L. So this way, when we're at this point, we have calculated, we have a dictionary called retval with the number, with the character being the key and the number of occurrences as the value. And once we have that, for all the children, we can pretty much return it. Let's see how we would do this. So if, but the returning value is actually an array of the number of occurrences of those letters, right? So we can say self output is equal to an array of zeros times n, and in which case for here, each time we compute the value for one of the given nodes, we can say that self output of the current is going to be equal to, this is going to be here, and this is going to be equal to the ret val of L, of the current, sorry. Except that the current doesn't actually mean anything, it's going to be L, and it's going to be a label, right? No. This is the current because we don't care about the position of the string in this label. We care about the node that we're looking at. So current ret val, and here L is not even label. Okay. So now that we've populated this thingy here, let's say self DFS, current being 0, labels, and tree, those 3 entries. Okay, let's run it and see what happens. DFS must be of type. What if I just say dict? Wrong answer, output none because I didn't return anything. Sweet. Let's submit this. Wrong answer. Interesting. Pretty close though. I think we have probably some edge case. Let's add this edge case to the test suite and see what's going on. This edge case. In this edge case, we have a tree that looks something like 0. Let me write this down here. 0. Then here we have 0, 2, and 0, 3. 0, 2, and 0, 3, and 2, 1, 2, 1, 2. So that's probably why it's happening. If this said 2, 1, then we would, if this had 2, 1, that we would actually visit this 1 node here. But since it doesn't say the right order, the from and the to order, I'm guessing that it's just skipping out on this guy completely, because it only sees the key value 0 and 1, and 1 is never reached through here. So, okay, a way we could do that is by obsessively populating this tree node. A way that we can deal with this issue: if B not in tree keys, we could say tree B equals empty array, and we can say tree B append A. And now what could happen is, since we start with 0, let's actually see what this tree looks like before we do anything. Output is still print tree. 0, 1, 2, 4, 5, 6. So yeah, now it populated the. Oh no, I wanna look at this. It populated all the keys as nodes, but when we look at 0 and it goes to 2 and 3 and does the whole procedure for the 2 and the 3, when I look at 2, it's going to try to compute this for 0 as well, and it's going to go into an infinite loop. Something that would not happen before, because 2 would never have a parent, or would never have a child 0. So what we can do here is, if child, I guess we can introduce another variable here, current, and parent. Current and parent. The parent here would be the current. And I say if child equals current, then continue. If parent equals to continue. And then here, -1. This is a trick, I guess, a workaround, because we have this weird condition where if current not in keys, maximum recursion depth exceeded. What is going on? Tree keys. Tree keys. If current not in tree keys, then return the and set the output of the current to 1. Guess that's wrong because current self put current equals 1. Did I not return something? Well, I'm just thinking, why would there be a maximum of recursion depth exceeded? Like, are we not catching some sort of um case where parent is I have to say parent, because if it's not the parent, then oh, sweet. Sweet. Yep, those are the wrong answers. Sweet. Okay, so let's talk a bit about the solution. Let's find if there's actually, this is pretty good. It's pretty good timing wise, but let's look at another. I guess the thing that would be most confusing to me is this data structure, right? What does adding another mapping from child to parent actually do? Well, previously the issue was um, the node that I cared about, which was node number 1 in a layout like this, where there's a 0 and then a 2 and then a 1. Uh, 0, 2, and then a 1. This 1 would never be reached because there was never an edge saying 2, 1. The edge was defined as a 1, 2, and or the edge was defined as 2. The edge was defined as 1, 2, but the edge 1 was never included in that tree graph. And so what we're doing here is we're forcing all different combinations of parent-child relations between the nodes to be put into the tree. But what that introduces is a possibility that a child could recursively call the same itself on the parent, because now the child also has a parent as one of its children. And the way that we're stopping that is through this. We're saying that if child equals parent, then skip out of this loop. Um, we are we have the tree defined pretty well, but that minor detail makes it almost uncatchable. So I've actually introduced this from a previous similar question that was doing something relatively similar, where there was a tree defined, but it wasn't defined in terms of nodes and the relationship to other nodes being within the nodes class variable. It was a collection of edges, which was just an array. It didn't define the from and the to too explicitly. So let's look at another implementation. Not sure if I have enough time to get through this. I'm having some technical difficulties with the software that I use to record these videos. Used to use Loom, but Loom put a restriction on the time that I can record a video to 5 minutes, and so now I had to move to another solution. Yeah, if you guys have another solution to making this circular video, circular self the webcam be visible while I code, then please tell me no. Okay, I'm not gonna have time to go through this, and to be completely honest, this is completely different from what I had. Although they still do this, they still do this same approach where they have a structure called nodes, which is in our case was called tree, and they overflow the um, they overpack the structure with all sorts of combinations, and then somewhere here, yep, they see the next node is not equal to the parent node. So yeah, and interestingly, they say here's none, but they didn't actually return a response, and the response is the same thing that I have, except this is a array, which we could have done too. Could have done an array instead of a data structure. So yeah, yep. Stay tuned. There was an issue with, as I said before, the video recording tool. So yesterday I skipped, but we'll upload the video to YouTube today probably. All right. So thanks for tuning in. Bye bye.